All right, send in all the words that you have typed so far. It's okay if it's incomplete. Just send it in. Let's see. Send in all the words which you think are relevant, which we talked about in the class that caught your attention, or relevant to the subject. Nobody's, there are no words, nothing that you learned in the last few weeks. There is no response. So I didn't teach anything for past 2 weeks, is it? All right. I see one response. Others? Is it my internet and I'm worried? Or is it? So there is nothing else I taught it is taught there, is it? Compound interest, simple interest. What else? Geometric progression. Yes. Oh, it was as simple as this. I taught you about simple interest, compound interest, geometric progression, investment, and that's four ideas as simple as that. Okay, that's interesting. That's pretty much the major keywords that we came across. Please feel free to go ahead and post if there are more words that you remember. This is a way for us to recollect whatever we went through so far. All right. Now, let's get to our business. Yeah, principal versus principal. They were homophones. That is similar sounding words. And we were confused about the spelling. Did we fix on which spelling yet? We didn't, right? Okay. So I can make that one of the questions for our midsem. Can we? Principal versus principal, which is the right spelling? Okay, I'm just joking. No. Okay. So things are simple, especially for midsem. It is very simple. It's about calculating simple interest or compound interest. Or given the maturity amount, find the principal investment, or find the interest rate and different things, time period and everything. So it's simple as that. Questions will be simple for the midsem. Please prepare well. And also we did something last week, right? Recurring deposits. All right. So here, that's where we came across geometric progression. This is another question with in the same context. Rupees 10,000 now and rupees 10,000 each year for 5 more years. And we have to calculate the total investment after total return after 6 years. How do we do it? how do we write the answer? We can always draw a picture to make things easy. One is here, 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Okay. I wrote 7. I drew 7. Okay. This is the 0th year, which I am investing now. And this is the first year, second year, third, fourth, and fifth. Oh, wait, 6 years, right? Okay. Yeah, that should be one more. I'll confirm that because I would love to allow you to use calculator, but there has been exam section had made some clarification about maths papers and calculator. I'll confirm that. Just remind me in one of, like, hopefully, preferably tomorrow morning. I'll confirm that with the head of the department and get back to you. All right. Your question whether calculators can be used. Okay. So now we are putting in rupees. We are investing rupees. How much are we investing? Rupees 10,000. All right. Rupees 10,000, which is going to stay for 6 years. Therefore, after 6 years, the maturity amount will be 10,000 into what will be the maturity amount? The initial amount into 1 plus what is the rate of interest? 1 by 8 by 100, 8% to the power the term, 6 years. Now, into this is nothing but 1.08 to the power 6. And we put another 10,000 1 year later, which becomes into 1.08 to the power 5, which will remain for 5 years. Similarly, again 10,000 to turn out to be into 1.08 to the power 4. Again, rupees 10,000 to turn out to be into 1.08 to the power 3. Going forward, fourth year, I am investing again rupees 10,000 into 1.08 to the power 2. Fifth year also, we are investing rupees 10,000, which becomes that into 1.08 to the power 1. Now, adding these up will be our total amount. Therefore, maturity amount is equal to 10,000 into 1.08 to the 1.08 plus 1.08 to the power 2 plus etc. plus 1.08 to the power 6. Now, this will be equal to, can you tell me what will be the answer? We will use the geometric progression, which is in geometric progression with first term is equal to 10,000 into 1.08. Common ratio is equal to 1.08. And what else do we need? N is equal to 6. So therefore, maturity amount is equal to, we can use the formula for geometric progression. That is A into R to the power N minus 1 divided by R minus 1, which is 10,000 into 1.08 to the power 6 minus 1 divided by 1.08 minus 1. Can you tell me what will be the final amount? Can you tell me what will be the final amount? What will be the final amount if you calculate it this way? Are you guys there? $5,068. $73,350. What about others? $73,359. Okay, interesting. $73,250. Okay, why are we getting different answers for the same formula? All right, let me see. I think we have one way to do it right here. Okay, let's try that because why not? Technology is here for us, right? Let's use the technology. Okay, somehow technology is failing us as well. So, all right, yeah. Okay. Okay, yeah, it's not working. We'll just go ahead. And in fact, if you calculate, the answer is going to be, so there's actually an option called into math, and they solve the math for you if you do that. But I was trying to use it, but unfortunately, the system's catching up with everything a bit. So the answer is going to be 7,359. Yeah, 0.29. Okay, let's go up to 2 digits. Rupees 7,000. Sorry, 73,359.29. So we investment is rupees 50,000 in total. Return is rupees 73,359.29. Well, we'll verify one more thing. What if we invested rupees 50,000 in one sum for 6 years at 8% interest? What if we directly invested compound interest of 50,000 for 6 years at 8%? What would be the return? So maturity amount in this case will be equal to 50,000 into 1 plus R by 100, that is 0.08, divided by, it's compounded annually, so divided by 1 to the power 6, which is equal to, what will this be equal to? The case I am presenting is, what if the maturity amount was, what if we invested all 50,000 together for 6 years at 8% interest? What would be the return? Did anyone calculate? What did you get? $79,343.7. Yeah, you're right. Why did you delete your answer? So you would have got, which would have been more? Is investing in recurring deposit better, or one-time investment of rupees 50,000 is better? Any conclusions? Okay, let me do that. Let me put a poll. Put a poll. Let me see. Let's take the poll out of the. Okay. So, okay, let me see. I think they've taken the forms out. Anyway, that's not. Yeah, forms. Okay. Anyway, yeah. Can someone put it in the chat box? Which one? Clearly, if you notice, the forms is not working. Anyway, clearly, if you notice, recurring deposit is giving us much less return. See here, it is giving 73,359, while your other direct investment is going to give you 79,000 something. So clearly, recurring deposit is much weaker. But why do we need the idea of recurring deposit? Why not save it up to, say, 6 years, or in 3 years, save up 50,000 and deposit? Let's see. Suppose here you are putting 10,000 per year to for 5 years to get the maturity amount. What if instead of that, we invested all rupees 50,000, saving up for 3 years at 8% for 3 years at 8%. That is, in 3 years, I'm going to save up 50,000, and together as 50,000, I'm going to deposit the amount at 8% itself. What would be the return? Maturity amount will be 50,000 into 1 plus 0.08 to the power 3. That will be, because you're getting interest only for the 3 years you're investing. That would be 62,985.6. See the difference? We may not be able to invest that high amount in one shot. That's why we have the idea of recurring deposit, where monthly or yearly you pay a certain amount. And some recurring deposits are really nice, where you can pay a certain amount every month and monthly interest is credited back to your account. That was some way of doing some interesting recurring deposit work that way. So see the advantage, right? Recurring deposit, if you cannot raise all 50,000 together, you can raise bit by bit over the time, and you will get interest for whatever is invested again and again. While if you deposit everything together is another case. For example, say you got a job, you thought you'll you have a salary of 25,000 or 30,000, say. Your daily expenses are done at 25,000. Now, in the first month, can you put a deposit of rupees 50,000 straight out? You cannot. Instead, you start a recurring deposit, where you invest 5,000 rupees every month for 10 months. That would add up to 50,000 total investment. In the 11th month, you would have got a higher return. That's the idea. And recurring deposits are the best way to save, because it's a small amount every month and returns better than saving it up for a big investment later. Therefore, recurring deposits are one of the best way to save. All right, now that is recurring deposits. Now, remember last week I showed you another image. I showed you 2 images, right? One was recurring deposit and the other was SBI Dream. That is, you fix a time. In this time, I'm going to buy something. For this, I need this much amount of money. So depending on the rate of interest and term period, they'll say you deposit this much amount of money every month. These are called sinking deposits. All right. A sinking fund is an investment into which equal annual installments are paid in order to earn interest, so that by the end of given number of years, the investment is large enough to pay off a non-commitment at that time. For example, say right now, one of the new phones that was released is Samsung Galaxy S23 Ultra. Very costly, right? Nearly 1.5 lakhs. Now, you want to buy it. You are planning to buy it in 6 months. You decided to start a dream or sinking fund, where you're investing monthly this much amount and same amount every month. But at the end of, say, 5 months, you should have rupees 1.5 lakhs with you. Let's do that. Let's see. Okay. Now, sinking funds. Samsung S23 Ultra is our aim, which is priced around rupees, I think, 1,50,000. Let's approximate it at that. 1,50,000. All right. Now we need to know how much should I deposit each month to buy the amount in interest. So let's say, let's put it as 5% per month, and I'm going to invest for buy in 5 months. Question is, how much is the amount I should invest every month to have a saving of rupees 1,50,000 after 5 months? Let's see. Now, we know that we are going to invest at 5% per month, right? So let A be the principal or initial investment. The word we haven't confirmed yet. You guys have to tell me. Investment. We are investing rupees A, and let's draw the timeline. We are going to invest for 5 months. In 5 months, we are going to buy. So now we are going to invest rupees A. We don't know how much it is. And we are going to invest for month 1, month 2, month 3, month 4, month 5. 1, 2, 3, 4, 5. Rupees A is invested for 5 months at 5% interest. So 1 plus into 1 plus 0.05 to the power for 5 months, right? To the power of 5. And same rupees A is invested for 4 years into 1 plus 0.05 to the power 4. Same rupees A is invested for 3 months, 5 to the power 3. Now, going here, again, in the third month, we are going to invest rupees 3 at 0.01 plus 0.05 to the power 2. And fourth month also, we are going to invest rupees A. That will be multiplied by 1 plus 0.5. Now we need to find what is the amount we should invest, right? So therefore, A into 1.05 to the power 5 plus 1.05 to the power 4 plus etc. plus 1.05 is equal to 1,50,000. We need to find A. How do we find A? Of course, you can find 1.05 plus to the power 5 plus 1.05 to the power 4 plus etc. A is equal to 1,50,000 divided by this amount. Or let's work smarter. Because our which LHS is in GP with initial term is equal to 1.05, common ratio is equal to 1.05, A into 1.05, sorry, A into 1.05, common ratio is equal to 1.05, and number of terms is 5. Therefore, let's call this equation 1. 1 implies initial term A into 1.05 into r to the power n, r to the power 1.05 to the power 5 minus 1 divided by 1.05 minus 1 is equal to 1,50,000. 1,50,000. All right. This implies A is equal to, you can now do it, right? 1,50,000 into 1.05 minus 1 is 0.05 divided by 1.05 to the power 5 minus 1. What will be the amount? Can you put it in the chat box? What will be this amount? Will be equal to 27,146.22. Yeah, rupees 27,146. Say, you got the idea, right? But why do we multiply A with 1.05? See, if you are just considering this as your, if you are just considering this as your geometric progression, you have to do A into whatever is the ratio that you are dealing with. Then again, it will be A into 1.05 into, first term is 1.05 into 1.05 to the power 5 minus 1 by 1.05 minus 1. Or you take the first term to be A into 1.05, second term to be A into 1.05 to the power 3, 2, and so on. Either way, we are going to come to the same formula. That's the point. What I'm saying is, okay, or a better way to say is, try to write it that way. Okay, did I understand your question correctly? That is another thing I want to clarify. You can clarify it, I can tell you. Okay, because the thing is, how I understood is, if I'm doing A into this entire thing, but this is a GP, that this is a GP, and that's how I understood. Then why do we take first term to be A into 1.05? You can take this as a GP separately. Even then, what I'm saying is you'll reach the same expression, which is here, the same expression. You'll reach the same expression, is what I'm saying. Or another angle I can think of is, why is our first term A into 1.05? Because what we are going to do is, we are going to add these amounts up. This is the interest obtained in various years for recurring investments we are making, various months. We're going to add these up. First month's investment is going to give a return of A into 1.05. That's why this equation came up. This particular expression came up. Okay, I'm not sure whether I clarified. If there is anything, please do ask. But say, there is another question. So you have to invest rupees 27,146.22 every month in order to get 1,50,000 after 5 months at 5% interest. Instead, suppose you decided you're not going to deposit, you're going to save required amount. You're going to equally divide and save required amount for 5 months. 1,50,000 saved over 5 months will be rupees 30,000 every. You see how the difference, you're just going to, without putting it in for a deposit, if you're just going to keep on saving, you decided, let me avoid the complication of deposit, let me save. Then you will have to save an extra nearly 3,000 or 2,900 every month in order to have 1,50,000 after 5 months. This is the advantage of sinking funds or the dream, SBI dream, that SIB dream that I showed you. There is a similar policy is there for every bank. It may come under different brands. Similar policy is there for every bank as well. All right, I'll do one thing. I'll give you a question and you can try that out. Meanwhile, obvious question. Did you guys learn something new today? If yes, please give some reactions. If no, give the surprise reaction so that I will know that I have to prepare way more for the class. If you learn something new, give a reaction, any reaction. Yeah, of course, let's give some meaning to the reactions. If it was happy learning, any reaction. If it was very exciting learning, heart. If it was I knew it already, or you can give, say, smiley. And if it was like, I didn't learn anything new, surprised. Okay. So I'll give you one more question. A farmer just bought a, let's call it a tractor. The tractor which has life of 10 years. At the end of 10 years, a replacement tractor will cost rupees, let's say, I don't know the price of tractors. I'm just going by a guess that it's around 10 lakhs. And the farmer would like to set up a sinking fund for the same. Same starting now, as in he just bought, but this month onwards he want to start contributing. What should be monthly investment if bank offers 10% interest per annum? All right, try this question. We'll start with this question tomorrow. Anyway, now we'll wind up the session for now. In another 10 minutes. So sir has scheduled this session for 3:50, right? That's because he's also in a theory. He's also in a theory class. He'll finish that, come running. We'll start the session. So we'll wind up our session. Try this question. Help the farmer save up for a new tractor in 10 years, because this tractor may go wrong. Its lifespan promised is 10 years. All right. So help the farmer to find out how much he should invest every month. All right. So with that small note, let's end the session and